Okay. This record. Share my screen. Okay. Uh, I'll just mark all present for now. Abalos, I'll just confirm.
Present for meeting.
Okay. Abdun Hussein. Abdun.
Yeah, yes, I'm
Okay.
present.
Um, Alkulaifi, Saleh. Alkulaifi. Nasser Mohammed. Absent. What about Alkulaifi Zayed? Zayed. Absent. What about Luis? Alviar Luis. Absent as well. Balagueo. Balagueo. Absent. Bantasha.
Present, sir.
Okay. Baren.
Sir, present.
Binggit.
Present, sir.
Bitanga. Absent. Bokari. Absent. Bondad. Absent. Kabangkala. Absent. Canas. Canas. Absent. Chiawan. Absent. Dakanay. Absent. Dacones. Absent. Delizo.
Present po.
Okay. Digap.
Present, sir.
Directo.
Present,
Sir,
sir.
Sir Dacon is po present.
Present.
Dacones. Okay. Directo is present. Esguerra. Absent. Felipe.
Present, sir.
Urboda.
Present, sir.
Sir Balagyo po present.
Okay. Ibrahim. Mohammed Ali.
Present.
Okay. Halyorina.
Present, sir.
Javier.
Present, sir.
Lee. Happened to Lee? It seems that Lee is not attending my class anymore. Mahamat. Hassan
Present,
Ali.
sir.
Madi.
Present, sir.
Mang Usan. Absent. Mendoza.
Meron, sir.
Absent. Ay, meron. Okay. Mohammed. Mohammed Magdi.
Present, sir.
Okay. Mohammed Osama Ahmed Saleh. Absent. Morales.
Present, sir.
Naoy.
Present, sir.
Okay. Obar is present a while ago. Okay. Olayo. Mang Usan is present. Okay. All right. Olayo is absent. What about Oredina?
Sir present.
Owatan?
Present, sir.
Pasqua?
Sir, present.
Popok?
Present, sir.
Yung kay Balagueyo, okay na. Na-present ko na yun. Balagueyo, here. Okay na, Mr. Tom Wilson. Nasaan na tayo? Sariliana.
Present po, sir.
Tang. Tang is absent. Valdez.
Present, sir.
And Wawa.
Present, sir.
Okay. All right. So let us proceed now to the next module. So we just finished having our quiz yesterday in module 1.2. So this meeting, so we are now going to discuss the 1.3. So we have a lot of topics, but most of them, or all of them rather, are about equations. Okay, so we have linear, we have rational, we have quadratic, and then we have system of equations. Okay, so let's proceed now with defining what is an equation. An equation is a statement that the values of two mathematical expressions are equal, indicated by the sign. So if it's just a number, then that is just a number. If it's a number with a variable 1 plus x, then 1 plus x, then still just, a term, two terms, or binomial to be exact. Okay? Or okay, let me just erase that one and then let's have a new one. Or let's say a polynomial. Okay. Okay. So this is just an expression or a polynomial to be exact. Okay. So the only time that this would become an equation is if there is an equal sign. Okay, it could be equal to 0 or it could be equal to a constant again, let's say 2, or with another expression, let's say 2x plus 1. Okay, so that is an example now of an equation. That is because we now have an equal sign. Okay, so of course we have a lot of operations of transposition of equation. If equals are added to equals, the results are equal. If equals are subtracted from equals, the results are equal. Multiplication, division, power, and then and so on and so forth. What it's trying to say is that if you added, okay, 1 on the right side, let's say plus 1, you must also add plus 1 on the left side. Okay? That is because, we do not want to change the original value. We just want to maybe tweak, we just want to do something, but we're not really changing the value of the equation. If you're going to simplify it, you would still get the same original value. Okay, if we multiplied the on the left side, then we have to do the one on the right side as well. For example, we want to multiply 2x, then do that one on the entire equation. Okay, if you want to divide, then you have to divide it on the entire equation. Let's say divided by 2, okay, or divided by 2x. You have to divide everything so that you're not really changing the value of your equation. You're just maybe simplifying it, you're just maybe trying to expand it, okay, but not changing the value. Okay, and so on and so forth, of course. So linear equations for one variable. A linear equation in one variable is an equation that can be written in the form ax plus b is equal to c. Okay, so this is the format of a linear equation. So ax plus b is equal to c as long as your a is not equal to 0. Okay, so let us have an example right away. Like for example, we have 12x 1. That's number 1. That's not 12. 1 is 2x plus 5 is equal to 9. So 2x plus 5 is equal to 9. If we want, let's say, to eliminate 5 on the left side, then we have to do the one on the other side as well. For example, if we want to eliminate the 5 by subtracting negative 5, then you also have to subtract 5 on the other side. Okay? So do that one on both sides so that you're not changing the value of that equation. So as a result, this is now 2x is equal to 4 upon simplification. Okay? So just interrupt me if if you have a question in mind, okay? So if all of you are, silent, no one's talking, no one's chatting, then I would assume that you guys can follow clearly everything that I'm saying in here, okay? So this is just the way to show that, on how did we transpose or how did we, remove this one, okay? So the other way is actually like, using transposition by just transferring that number to the other side, but changing the sign at the same time. So 2x plus 5 is equal to 9, right? If we want to, let's say, eliminate 5 on the left side equation, we can actually transpose this one to the other side. So how do we do that one? So just transfer it as it is. But change the sign from positive to negative. Okay? So it would go also with the other sign. Of course, if it's negative, then it would become positive on the other side. Okay? Okay, so sir, present po yung bondad. All right. Okay, let me just check the attendance of Miss Bondad. Okay. So let's go back here. Okay, so in here, upon simplifying this one, this would give us 2x equals to 4. Okay. So normally we do this one to, set aside everything that is constant on the other side and then set aside everything that is a variable on the left side. Okay, like for example here, if you want to remove the 2 again, okay, so we have to divide everything by 2. Okay, by doing that one, that would give us now only x is equal to 4 over 2 or just simply 2. Okay, so that's what we mean by this operations of transposition of equations. But if you already master that one, you don't really need to show everything. Like in this case, not erase. Where's the eraser? In this case, you can just transpose the 2 on the other side, like having x is equals to 4 over 2. Okay, so it is an understandable solution. And as a result, this would give us x is equals to 2, which would give us the same result as this one. Okay, so I hope all of you were able to get this one, the number 1. So just let me know if you have a question or clarification. So let us proceed now to number 2. We have here ax plus a is equal to bx plus b. Okay, so solution ax plus a is equal to bx plus b, or ax minus bx is equal to b minus a, or you can actually bring out the x to the left side. We give us now x times a minus b is equal to b minus a, or just simply, tweaking this one, we can transfer this one on the other side. So divide both sides by a minus b to cancel this one on the left side, and then that would now become a denominator on the right side. So we now have this one. It's x is equal to b minus a over a minus b. Okay, and then again, notice that this is positive b, this is negative b, this is negative a, this is positive a. So just by multiplying -1, okay, you can actually cancel out everything and then the retaining -1. Okay, so I hope you guys can still remember our discussion last week with the module 1.2 on how we cancel this kind of equation. Okay, so this is -1. So if a is equal to b, the equation is an identity and is true for all values of x. Okay, if the value of your value of a and b is equal, like of course 5 minus 5 is 1, 5 minus 5 also the denominator is 1, so 1 over 1 is 1. Okay, but for this one, we're assuming that b is a different value for a, so that is why, if we want to cancel this one, we have to multiply -1 on let's say to the numerator. Okay. So number 3, in here, your main goal here, exactly, your main goal here in number 1, 2, and 3 is to find the value of that variable. Like here, the value of the x is equal to 2. The value of, let's say, x is -1, or just simply b minus a or a minus b. The value of r is -2. Okay, that's what we're trying to do in these examples. So in here, we just simply, distribute your 4. 4 times 2r is 8r. 4 times -3 is -12. -2 times r is -2r. -2 times -4 is +8. So that's for the left side equation. For the right side, it's 3 times r is 3r. 3 times -3 is -9. And then followed by -1. And then simplify this one, or if you want, just rearrange it first, just like what happened in here. So all that has an r on the left side, and then all that is constant on the right side. Okay, 8r is 8r, -2r is -2r. 3r, if we're going to transpose this one to the left side, okay, then from positive, it would now become negative. All right. And then for the right side equation, so -9 is still -9, -1 is still -1. However, in here, we want to transpose the -12 to the right side, so that would now become +12. So the same thing here as well for the 8. So from +8, it would become -8. And then just add similar terms. So 8r minus 2r minus 3r is 3r. -9 minus 1 plus 12 minus 8 is -6. Then again, divide both sides by 3 to eliminate the 3 on the left side equation. So r is equal to -6/3. Simplifying further, that would give us -2. Okay, so were you guys able to follow so far?
Yes, sir.
Okay, very good. Very good for 1 out of 32. So I'm not sure with 31. So I hope you
Yeah,
guys are
we get
still
it.
there. Okay, so thank you for your response. Okay, so number 4, the same thing. So it's just a matter of how you tweak the equation on the left side and then right side, and then just retain all the, let's say, x on the left side, and then retain all the constant on the right side. So in here, okay, we can do cross multiplication for us to be able to get one single denominator. So by doing that one, okay, that would give us 3x plus 2 times x minus 1 over x minus 1 is equals to 3 over x minus 1. There you go. And then notice that we have the same x minus 1 on the left side equation and then right side equation. We can just actually just simply cancel that one out. Okay, because if I will transfer this one on the other side, they will just cancel. Retaining 3x plus 2 times x minus 1 is equals to 3. Now let's distribute. Okay, so 3x plus 2x minus 2 is equals to 3. So 3x plus 2x is 5x. Then I'll transpose -2 on the other side. So 3 plus 2. Therefore, our x is equals to, let's not do some shortcut for now. 5x is equal to 5. So therefore, our x is equals to 5 over 5, or just simply equals to 1. which is the same with this one. Okay, so I hope we're clear with example number 4. Number 5. So do the same thing. Just get the LCD. So you could follow this one if you want, or you can just have it my own way, just like now. Okay, the LCD for all of those is 8, correct? So 8 divided by 4 for the first one is 2. 2 times 3 is 6. That would give us 6x. Okay, so 6x. And then for the second one, 8 over 8 is 1 times 7 is plus 7. And for the last one, 8 over 8, 8 over 1, 8 divided by 1 is 8 times 1 is 8. So this would give us 6x plus 15 is equals to 0. And then transpose the 15 on the other side. That would give us 6x is equals to negative 15. And then divide both sides by 6. That would give us x is equals to negative 15 over 6. And then divide everything, numerator and then denominator, by 3. That would give us negative 5 over 2, which is the same with this one. Okay, so again, we have thousands or maybe millions of ways in solving a certain problem. So if you can have your own version, as long as all of your steps are valid and then we have the same answer, then I guess that's fine. Okay, so this is one way, or this is one way for you to solve this one. But as you can see, it gave us the same answer. Okay,
Can you
so
do it again, sir?
get the LCD, the least common denominator. Okay, so as you can see, the LCD is 8. Why is that? Since this is 1 over 1, okay, so 8, how would I get that? How would I say, uh, okay, as long as you will be able to divide, if this is your LCD, as long as you'll be able to divide this 1 to all of our denominators, then I guess you're fine. Okay, so we can have 12, okay? No, we can have 16 rather, because 16 is divisible by 8. Okay, and then 16 is also divisible by 4. 16 is also divisible by 1. However, this is not the LCD, because LCD is the smallest number that we can think of. That's why it's least common denominator. You know, you have to get the least common denominator of them. In this case, it's 8, because 8 is divisible by 4. 8 is divisible by 8. Okay, and then 8 is divisible by 1. So 8, for us to be able to get the 6x, so 8 divided by 4 is 2, multiply that 1 to 3, and then the rest, so 2 times 3 is 6, times x is now 6x. 8 divided by 8 is 1, 1 times 7 is 7, which is now this one. 8 divided by 1 is 8, times 1 is 8, which is now this one. And then just add similar terms and then transpose on the right side, the one that is constant, and then retain the variable on the left side for you to be able to get this one.
Yeah, I get it. Thank you, teacher.
Okay. All right. So yeah, that's it for the number 5. Number 6, solve for u, okay? So it's also possible that it would give you many variables, but you just need to find one variable, which is, in this case, it's u, okay? So you have to find ways to transfer this one on the left side and then the rest on the right side. That is not necessary. So what we can do is maybe eliminate the 1/2 by multiplying 2 both sides, okay? Which is now this one. Okay, just multiply. Okay, let's have our own solution. So multiply the entire equation by 2. So notice that it would become 2s. 1/2 times 2 is just 2, and then of course the rest will be the same. 1/2 times 2 is 1, so it's now v plus u times t. Okay, the u is still here, but what we can do is we can transpose the t on the other side, making it 2s over t is equals to v plus u. And then we can still transfer the v on the other side by making it negative 2s over t minus v is equals to u, which is now the same with this one. Okay, so if you want to get this one, then just do cross multiplication. Okay, so u is equals to, so 2s times, by default this is over 1. 2s times 1 is 2s, and then negative v times t is negative vt over t times 1 is t. Okay, which is now the same with this one. All right. So were you guys able to get number 6? So, so it's
Yes, sir.
how you mastered your transpositioning skills. If it's plus, it would become minus. If it's on the top side, transposing that one on the left side will become a denominator. Those cases. So yeah, math really needs practice. Okay, you cannot just master it just by watching. So you have to do it on your own. Okay, that is why we have a lot of practice exercises in every module. Okay, so we now only have a few minutes left. I'll just announce again for the part 2 so that we can continue our discussion. Okay, so too bad I don't have a premium version of Zoom meetings. So that is why we always have a limited time every meeting. Okay, anyway, so goodbye for now, and then I'll just wait you guys on the part 2. Okay.